Hello friends, welcome to the week 9 summary of NCER course under NPTEL 2019. So in this week we have to study ocean thermal energy conversion, that is OTEC. Now we have to see what are the principle of OTEC. The temperature difference between warm water at the surface and colder water approximately 1 kilometer below the surface is used to run a heat engine and energy is extracted from the same. Temperature difference can be of the order of 15 degrees Celsius to 25 degrees Celsius. What is the thermal profile of seawater? First 20 meter absorbs sunlight. Surface freezing at poles to 36 degrees Celsius in the Persian Gulf. Water turbulent and mixed for a few hundred meters. Boundary of a few hundred meters between mixed layer and undisturbed water below called thermocline. It is a layer between water. Now 90% of the seawater below the thermocline, the temperature of the water below thermocline is around 3 degrees Celsius, that is very cold. Now there are some challenges working under the sea, that is Mariana Trench, 11 km deep, visited by only 3 people ever. Moon, nearly 384,400 km, and it is visited by 12 people. What is the difference? It is very hard to work under the sea in comparison to the working in the space. It is easier to work in the space than in the water because the pressure under water is very high. Now we can directly use the cold water in the sea for air conditioning work. Directly we can use. And we have to see water open cycle and closed cycle. Open cycle, warm sea water evaporates at low pressure, runs turbine, condensed by cold sea water, desalinated water becomes available. What is closed cycle? Low boiling point liquid, ammonia minus 30 degrees Celsius. Warm water makes it evaporate and run turbine. Cold water condenses it afterwards. So what are the conclusions of OTEC? That OTEC is available to tap in almost all coastal regions. It can be set up offshore as well. Efficiencies are low. Stability of structures in the presence of water currents is a factor to address. Now it comes geothermal energy. The cross section of earth, that is crust, upper mantle, lower mantle, outer core and inner core. The thickness of all these are given, that is 37 to 7, 20, 21, 6, 70, 22, 60, 12, 20. So what is core? That is made up of iron, nickel, noble metals, mantle, sulfide, oxide rich, crust oxides. Now the depth of all these cross sections of earth are given, that is crust 30 km, upper mantle 750, lower mantle 2920, outer core 5180, inner core 6400, and the temperature is also given. Crust 0 to 700 degrees Celsius, upper mantle 1000 degrees Celsius, lower mantle 3500, outer core 4000, inner core 7000. Now what are the deepest spots in the oceans? The Challenger Deep Mariana Trench, that is 11 km deep in the Pacific Ocean near Japan. Deeper than the height of Mount Everest. It is deeper than the height of Mount Everest and it is the deepest point in the oceans. And what are the deepest spots in the lands? That is drill hole in Soviet peninsula of Kola, that is 12 km deep. That is in lands, but in oceans, Mariana Trench is the deepest. Now we can determine the composition of Earth by determination of following things, that is flow of heat from inside Earth, experiments on surface, mineral and rocks under high PT, pressure and temperature, gravity and magnetic fields of Earth, path of earthquakes, waves traveling through the Earth. Now what is the principle of geothermal energy use? Says that temperature gradient is of the order of 25 degrees Celsius to 30 degrees Celsius per kilometer. 20 degrees Celsius per kilometer in northern latitudes, 40 degrees Celsius per kilometer closer to equators. There are some more principles. That common usage 150 meter to 200 meter with temperature increase of less than 10 degrees Celsius. Oil industry drills 5000 to 10,000 meter temperature greater than 350 degrees Celsius. Electronics will struggle here and faults will enable access to higher temperatures. There are deep water horizon US Transocean 2010, that is 10.5 km deep. Sakhalin 1 Russia Exxon 2012, 12.3 km deep. And anticipated lifetime of geothermal energy is approximately 30 years. And there are some conclusions that geothermal energy preferably tapped near faults. Deep drills already being made of oil industry. Now there are some geothermal energy technological aspects. What is prospecting? To enable identification of better locations for plant, temperature is a function of depth. Tattapani, Balrampur district, Chhattisgarh. Helps identify low density regions for drilling. Nearly 40% of the cost of geothermal energy is associated with exploration. And what are large plants? Geysers Geothermal Complex, California, 1500 megawatt, and Philippines, US, Indonesia 2, Mexico, Italy, Iceland 1. So Philippines is having the 3 number of geothermal plants. Now, superheated steam that is rare to find, runner turbines should be corrosion resistant. Follow up with a condenser replenish the water. Saturated steam found relatively more often cannot be used directly since it can damage the turbines, heating, pressure, flashing. Hot water found in many places. Binary fluid cycle, butane minus 1 degree Celsius, isobutane minus 11.7 degree Celsius, or pentane 36.1 degree Celsius. Now the conclusions are geothermal energy is available with differing levels of heat. Geothermal plants have to be designed to account for the different prevalent conditions. And there comes the biomass. So background of biomass, power companies are under pressure to find alternatives to fossil fuels such as coal. Percent renewables in energy target: EU 20% by 2020, India 40% by 2030, US takes taking initiative likely 20% by 2020. Biomass, fuel derived from plant matter, and it is considered clean and renewable. So what is the overview? It is versatile, that is solid, liquid, or gas, already supplies about 10% of world energy demand. Both traditional small-scale wood gathering to large-scale farming process involved significant source of employment. Biogas agriculture, farmers grow corn for producing ethanol, alternate source of income, competition with food resources, and bio-waste. Straw. Biomass is often byproduct or waste product from agriculture. Straw is a major byproduct from grain production, 40% by weight of overall product. Billions of tons produced globally, only 100 million tons used, rest burned in the open or allowed to rot. Crop residue burning in October, November, and pollution in Delhi. Substitutions: coal, direct combustion of wood. Coal, charcoal, wood heated in absence of air, removes volatiles, twice the energy content per unit mass. Petrol, ethanol by fermentation of coarse sugarcane, anaerobic. Diesel, biodiesel from vegetable oil such as soybean oil. Natural gas, biogas from organic waste, that is anaerobic. Top 10 nations in biomass electricity: US is at the top position, China second, Germany third, Brazil fourth, UK fifth, India sixth, Italy seventh, Sweden 8th, Finland 9th, and Austria 10th. Now top 10 states in biomass capacity megawatt in India, with Maharashtra is at the top position with 1112, Tamil Nadu 662, Uttar Pradesh 937, and Karnataka 737. Now 32% of energy in country from biomass, impact 70% of the population. 5940 megawatt biomass based power plants, 4946 megawatt grid connected, 994 megawatt off-grid power plants. Baggies, major part of the above. What is baggies? Fibrous remains of the juice extracted from sugarcane. So biomass is clean. Biomass is clean. Carbon release is what was captured by the plant originally. Time scale, other opportunities, and it has no impact on wildlife. What are the time scale? Lifespan of a tree 50 years to 3500 years, and time required to burn a tree only a few seconds. So many things can happen to a tree as a part of natural process. Biomass is clean. Emissions from burning wood: CO2, CO, SOx, NOx. Emissions from coal: calorific value of wood, that is 15 megajoule per kilogram. Calorific value of coal 25 megajoule per kilogram. So wood is better option and biomass is better option. So what are conclusions? That extracting energy from plant or plant derived products is referred to as biomass energy. Carbon neutrality of biomass may be more complicated to estimate than previously assumed. Plant products can be directly used to fuel power plants or converted to petrol or diesel and then used. Now there are some important key points, you have to listen them very carefully. Temperature deep inside the ocean is relatively unchanged by the time of the day, and OTEC based systems are low in efficiency but can be tapped abundantly. And there is a boundary between mixed up water at the top of the ocean and undisturbed water deep inside the ocean. And cool water from the deep inside the ocean can be directly used for air conditioning. And low boiling point liquids can be used in a closed cycle to run turbines using the temperature difference between warm and cold sea water. And composition of earth can be determined in part from information on how earthquake waves travel through the earth. And use of biomass represents a capture and release of same amount of carbon and hence is considered safe for environment. So thank you very much. This was from week 9 summary. Now we are moving towards the week 10 summary in the next video. So see you there soon.